So in this video we're going to look at heating fuels for the home. So here is a list of heating fuels that can be used to heat your home. Okay, and these fuels are basically used to heat water, which is usually then used to warm up your radiators. Electricity sometimes works slightly differently and is used to power a storage heater, but basically these other things are used to heat water in your home. Sometimes wood is just used in a wood burning stove just to directly heat your home from that wood burner, and the same for coal. But those stoves often also heat water, which can be used to produce hot water for your house and possibly to heat radiators around your home. Okay, so the question here then is, we're going to compare the cost efficiency and environmental impact of the different fuels used to heat your home here. So firstly, let's talk about cost efficiency. So we're given the fuel price per unit in this column. We're given the unit in this column. And what you'll notice is the unit of each of these fuels is different. Electricity is measured in kilowatt hours, gas is measured in kilowatt hours, oil is measured in litres, LPG is measured in litres. Oil and LPG is liquefied petroleum gas. These are both liquids. Gas is obviously a gas. Electricity is neither solid, liquid or gas. It just travels through cables to your home. Wood is a solid. Ground source heat pump is the heat that you get from underground. And coal is a solid. So they all have different units. So what happens then is they use the fuel price per unit and the different units, and they adjust this then to get the cost per kilowatt hour. And that's what we need to work out the cost efficiency. Okay, so if you look at the numbers here, electricity has the largest number, okay, and oil has the smallest number. Okay, now you don't need to worry about this percentage here. The percentages here just talk about the efficiency of the boilers, okay, and they have different efficiencies, and that's taken into account in these calculations. This might seem a bit odd, 350% efficient here, but that's just due to a strange, slightly odd way in which they calculate that value, but you can just ignore those percentages, okay. The question is, it's this number here that we're concerned with, okay, because this is the number that gives us the cost per kilowatt of these fuels, cost per kilowatt hour I should say, for these fuels. Okay, and the kilowatt hour is the unit we use to measure the amount of heat provided to the home. So electricity has the largest number, oil has the smallest number. The question is, do we want our fuel to cost a lot for every kilowatt hour of heat produced, or not a lot? And the answer is, you want it to cost the least amount possible. So oil is the most cost efficient as it has the lowest cost per kilowatt hour of heat provided. Okay. And you can say that electricity is the least efficient as it has the highest cost per kilowatt hour of heat provided. Okay, so that's the cost efficiency. Now the next thing we're asked to talk about is the environmental impact. And the thing that affects the environmental impact is the carbon dioxide emissions per kilowatt hour. So think about it. Do you want a lot of carbon dioxide emitted or a small amount? And I hope you agree, you obviously want a small amount. The fuel that has the largest CO2 emitted per kilowatt hour is electricity, and the fuel that has the smallest amount of CO2 emitted per kilowatt hour is seasoned wood. Okay, so electricity, you can say, has the greatest environmental impact as it produces the largest amount of CO2 per kilowatt hour. Okay, and you can say that wood has the least environmental impact. Okay, because it produces the lowest amount of CO2, carbon dioxide, per kilowatt hour of heat produced. Now, this electricity here will only produce a lot of CO2 if the electricity is produced from coal, oil or gas. If this electricity is produced from solar panels, then this value will be much smaller, but in this case that it must be produced from something like coal, oil or gas. The reason that wood only produces a low amount of CO2 is because although wood, when you burn it, releases CO2, if you think about it, the trees that we use to produce that wood, they take in carbon dioxide in photosynthesis as they're growing, and therefore the net release, the overall release of carbon dioxide from a tree is very low.